In this video, we will go through question 11 and 12 from AS 2018 paper. Okay, question 11. It says, find the first three terms in ascending power of x of the binomial expansion of 2 minus x over 16. Okay, giving your answer in its simplest form. Okay, let's write down the formula first. 9c0 2 to the 9 minus x over 16 to the power of 0. Add 9c1 2 to the power of 8 times by minus x over 16 to the power of 1. Add 9c2 2 to the 7 minus x over 16 to the power of 2, and so on. So we are just required to find up to 3 terms. Using your calculator, you should be able to get 9c0 2 to the 9. 9c0 is 1 minus x over 16 to the 0 is 1. 2 to the power of 9 is 512. Similarly, 9c1 2 to the power of 8 times by minus x over 16. It should be minus because minus x over 16 to the power of 1 is minus negative numbers. So it would be 144x plus 18x squared, which is in its simplest form. Okay, the next part of the question, it says that f of x is equal to, for part B, f of x is equal to a plus bx times by 2 minus x over 16 to the power of 9, where a and b are constants. Given that the first two terms in ascending power of x in the series expansion of f of x are 128 and 36x. Find the value of a. Okay. So in fact, this one is equal to, let's label it as a b, 128 plus 36x plus so on. Okay. So let's expand this one. A plus bx times y. 2 minus x over 16 up to 3 terms is already here, which we worked it out. 512 minus 144x add 18x squared, which is equals to 128 plus 36x and so on. Okay, so let's expand it. To get the first term, all we need to do, just multiply the constants. A times 512, which is 512a equals to 128. Because if we multiply a by any other one, minus 144x, 18x squared, and so on, we should get terms in with x or x squared, which is not for the first one. Okay, so therefore, a is equals to 128 over 512, which is, after simplifying this, we should be able to get 1 over 4 or quarter. So to work out b, all we need to do, find out which terms has got x. Okay, a times minus 144. Minus 144 ax plus 512 bx is equal to 36x. If you multiply any other terms, okay, you should get either x squared or a term without x. So if you factorize from x, divide both sides by x, you get minus 144a plus 512b is equal to 36. Okay, so now substitute a, you get minus 144 times quarter plus 512b equal to 36. Okay, and 512b is equal to 36 plus 144 over 4, which is 72. Therefore, b is equal to 9 over 64. Okay, so it was part A and this one, part B, and this one was part C. Okay, work out B for part C. Okay, end of the question 11. Now, let's move on to question 12. Let's move the paper a little bit aside. Okay, we've got enough space to write. Question 12. Okay. Yes, I put the question here just to read through. Okay. It says, show that the equation 4 cos theta minus 1 equals to 2 sine theta times by tan theta can be written in the form of 6 cos squared theta minus cos theta minus 2. Okay, so let's write down the question for cos theta minus 1 equals to 2 sine theta tan theta. We need to write down everything in terms of cos theta. So all we need to do, write down tan theta as a sine theta over cos theta. So therefore, 4 cos theta minus 1 equals to 2 sine theta times by sine theta over cos theta. Okay, 4 cos theta minus 1 is equal to 2 sine squared theta over cos theta. Multiply both sides by cos theta, you get 4 cos squared theta minus cos theta is equal to 2 sine squared theta. We know that sine squared is the same as 1 minus cos squared. Therefore, 4 cos squared theta minus cos theta minus 2 times 1 minus cos squared theta is equal to 0. 4 cos squared minus minus becomes plus, plus 2 cos squared, which is 6 cos squared theta minus cos theta minus 2 equals to 0. Okay, so that is what we needed. Okay, next part of the question. Let's see what it's asking for. Hence solve for x between 0 to 90. 4 cos 3x minus 1 equals to 2 sine 3x tan 3x. Okay, it is very similar to the previous one. In the previous one, we've got 4 cos theta. Here we've got 4 cos 3x minus 1, 2 times sine theta, 2 times sine 3x, tan theta, tan 3x. So the only difference is here, theta has been changed to 3x. Okay, so we want to solve for cos 3x minus 1 equals to 2 sine 3x tan 3x. If we could write down 4 cos theta minus 1 equals to 2 sine theta tan theta as a 6 cos squared theta minus 2 equal to 0, then we can write down this one as a 6 cos squared 3x minus cos 3x minus 2 equals 0. Okay, so it looks like it is a quadratic equation. Okay, so we could easily factorize this using your calculator. You can easily factorize 3 cos 3x minus 2 times by 2 cos 3x plus 1 equals 0. Therefore, cos 3x is equal to 2/3 and cos 3x is equal to minus 1 over 2. Okay, so using the calculator again, cos minus 1 of 2 over 3, which is the same as 3x, okay, must be equal to 48.2 degrees. 3x is equals to 48.2, x is equals to 16.1 degrees. Okay, so we could carry on for further, obviously, but since it would be out of range, so that is why I didn't continue here. But for next one, we might need to carry on for the further angles. Okay, so another one, 3x is equal to cos minus 1 of minus half. So 3x would be equals to 120 degrees. That's the first one. Okay, so if we take away from 360, we get 240 for the next one. Okay, so x is equal to, if we continue further, again it would be out of range, so we just stop here. X equal to 40 degrees, and for this one, x equals to 80 degrees. So therefore, there are three solutions: 16.1 degrees, 40 degrees, and 80 degrees. Okay, so end of the question 12. And in next video, we will go through the remaining questions.